With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In the given circuit, determine the equivalent resistance. And if you see in the second part, current in each resistance, potential difference across each resistance. So let us find out. If you see, the equivalent resistance will be the resistance of the circuit. So if you see, there are three resistance and one internal resistance, and all of them are connected in series. So I will write down R equivalent is equals to 3 plus 2 plus 4 plus 1, right? So it is 10 ohm. So equivalent resistance is 10 ohm here. Now if you see, the current in each resistance will be the same. If I write down, it is I, so it will be E by R equivalent. That is 10 by 10. So it is 1 ampere. So the current in each resistance will be the same and it will be 1 ampere. Now potential difference across each resistance. So if you see here, the current through them is 1 ampere, right? So if you see, if I say this is R1, R2 and R3, then the potential difference across them will be what? IR1. And if you move in the direction of current, potential decreases, right? So these will be the current, right? So if you see here, if I write down the potential difference across the three resistor, it will be I1, R1. So it is 1 into 3, it is 3 volt. 1 into 2, it is 2 volt. If you see here, the third one is 1 into 4, it is 4 volt. So 3 to 4. 3 to 4 are the potential difference across them. 2 volt. Now let's move to the DEF. So if you see, the rate at which the chemical energy of the cell is consumed, the rate at which the heat is being generated inside the battery, electrical power output. So if you see here, the chemical energy, if I write down the consume, so chemical energy will be consumed, it will be simply, if you see here, if you see, the chemical energy conservation will only depends upon this and this, the charge, the current through the battery times this potential EMF of this battery, right? So rate of chemical energy conservation, consumption, it will be E into I. So it is 10 into 1, it will be this. Now if you see the second part, the rate at the second part is the rate at which the heat is being generated inside the battery. So if you see, internal resistance is 1, so it will be I square R, right? Heat generated. So if you see, this is, this we will write down, it is V into E into I, it is 10 volt. Now E part, we will get the heat generated inside the battery, heat generation rate, it is simply I square R. That is 1 square, R is 1, so it is 1 only. Now the third part, F. If you see here, in the F part, we want the electrical output. So electrical output will be what? This minus this, right? Electrical output. It will be the chemical energy consumption minus the heat loss. So it is 10 minus 1, so 9 volt. So 10, 1, 9. So let me write down this. Now moving ahead. Which resistance will consume the maximum power? So since they are in series and the power consumption will be I square R, right? So current is same, so power is directly proportional to resistance. So the one which is having most resistance, so this 4 ohm. Now power consumption, dissipation in 3 ohm. So if you see, it will be I square R. If I write down this is P1, it will be I square R1. I is 1, so it will be 1 square into 3, it is 3 watt. So this is 3 watt. Simple, so these will be the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.